Good morning, everyone. Good morning, good morning. A warm hello from the warm Dublin. It's nice and warm this morning here. I'm Halleluya, and I am hosting this session with Filipa, who is sitting in Portugal. So please feel free to tell us in the chat where you are joined us this morning from, or this afternoon or evening from. And we have two speakers lined up for this morning from the Geological Surveys in Southern Africa. So Geological Survey of Namibia and the Council for Geoscience in South Africa. So stick around to hear about the exciting projects and work that two geological surveys have been working on or are planning on conducting in the coming weeks, months, or years. Filipa, over to you.
Hey, thank you, Halleluya, and good morning, everyone. I'm hosting you from Portugal. My name is. I will be co-hosting this meeting with Halleluya. So thanks for joining us today for our REX on African exploration projects. We want to thank you again to attending today and our co-sponsors, the SEG, the SGA, and IAGOD for making this possible. Halleluya, over to you.
Thanks, Filipa. It's my pleasure to introduce our first speaker for this session, Nguno. Nguno is the head of the Regional Geoscience, the mapping division within the Geological Survey of Namibia at the Ministry of Mines and Energy. For the past 22 years, she has been working as a geologist in various positions at the Geological Survey of Namibia. Her work experience includes, but is not limited to, compilation of geological maps, coordinating geological mapping, and research collaboration with local and international research institutions and researchers. She also has experience in GIS and remote sensing, as well as data management and geoscience data. Ms. Nguno is the president of the Geoscience Council. She's also part of the Geological Society of Africa and a Secretary General for the Subcommission for African Maps and Commission for the Geological Maps of the World. She is also a member of the AU African Mineral and Energy Resources Classification and Management System, and working part as a part of the technical working group. Anna, the next 15 to 20 minutes are yours, so please take us away.
Good morning, everybody, or evening, where you are in the world. Thank you for this opportunity. Halleluya already said, I'm Nguno, and then a Deputy Director at the Geological Survey of Namibia. My talk will be more on the Geological Survey of Namibia supporting mineral exploration. The outline of my talk, I'll then be more or less conscious, Earth Data Namibia, we normally call it EDN, and the promotion of the mineral potential of Namibia, and then looking at the collaborations opportunities. For Namibia, for the Geological Survey, we say it's centrally located in Nguno, and it houses information of about 100 years of exploration in Namibia, as well as modern geological information and data, and geophysical and geochemical data. We say most of the geoscientific acquired over the years has been through research, technical cooperations, collaboration projects, exploration activities, as well as government-funded projects. And some of this information has then been put in what we call the Mineral Resource Book of Namibia, which was then published in 1992. But since then, we have been updated the mineral book on the various form. Before I go further, I just want to say Namibia is still a country where mineral exploration is going on. Here, I'm just now showing you the two maps where we have the mineral exploration and then the hydrocarbon mineral exploration. And as you can see, for the mineral licenses, mostly part of the country is covered by the mineral explorations, where we look at whether it's exclusive exploration licenses that we call EPL or mining licenses, and the various licenses that we have in Namibia then. And we said for these mineral licenses, it's actually updated yesterday. And then if we look at the hydrocarbon licenses, well, the last update that I have, it was last year in 2020. So something might have happened, but that's how active when it's come to mineral exploration, Namibia is at this point. Well, we then go deep into the integrated geoscience mineral exploration database, Data Namibia. The Data Namibia, as I said, it's a database where we are trying to get in one place all the information that are related to licenses. And we're saying we got about 17,000 historic and active mineral licenses. We have got about 2,000 deposits and known mineral occurrences. And in the reports, geochemistries, drill boreholes, literature, and geochronology. All this information, it's made accessible to the stakeholder through the Earth Data Namibia. For now, unfortunately, if you want this particular data, you cannot get them via internet. You still have to email and put up a request. However, we do have let me say, let's first go into one of the module of the Earth Data Namibia, which is the mineral deposit occurrences. And then if you are then in the ministry or in the library, you will be able then to see what are the information that are included in the mineral deposit or occurrence. And here we are looking at a stream sediment map of Bramber West, and then it shows you the comment, the location, and what type of mineralization is captured there. And then you have also the map that shows you where this occurrence is. And so this is just an example of the mineral deposit or occurrence within the Earth Data Namibia. We then said, although you don't have access to the data via website yet, you can still then have a look at the Earth Data Namibia web application. So it gives you, if you look on your left side, then the geology, the geology map, the geology structure, mineral, the mineral license, the various mineral access, and then here I have just highlighted in red the mineral exploration report. So basically, you can be in your office where you can then look at the historic information and see the area of interest, whether you got reports there or not. So once then you find out that, okay, these are my area of interest, there are reports, then you can then email us, and then we'll be able to send you that particular information. As I said, we are working on getting people to be able to pay for some of the data that are able to be paid through internet, but it's a process that is ongoing. Here, again, when we are talking about the promotion of mineral of Namibia, we're looking at the airborne geophysical data sets, which for Namibia, we are proud to say the high resolution airborne magnetic and radiometric data have covered about 97% of the country at 200-meter line spacing and at the altitude of 80 meters. And we also then have the other airborne geophysical data sets, including the hyperspectra and the airborne electromagnetic survey, which at this point we have a coverage of 10%. What the Geological Survey is busy with is trying to improve on the coverage of the airborne electromagnetic surveys, specifically on the eastern part of the country, where it is covered by the Kalahari Sand. So that's one of the aim or that we are hoping that we can increase the coverage of the airborne electromagnetic survey. Another thing that is exciting for the people that will love to play with the high resolution airborne magnetic data, the Geological Survey is going to make freely available certain in the eastern part of Namibia, some of the data for a period. This is also something that once it's finalized, is going to be made known to everybody. Here now, we say if we're looking at the status of geological mapping in Namibia, when it comes to the 1 to 1 million, the country is fully covered. And then we have the different scales that are less than 250 that are then illustrated in the map. And the most important geological map that the Geological Survey has been working on, it's the 1 to 50 geological map, and that's in the southern part of the country here, and this has been done in collaboration with the Council of Geoscience, and we are also then proud to announce to say soon we'll launch a mobile app for the 1 to 1 million scale geological map of Namibia. This is again just to make sure that the information it's out there is accessible to the people that need it. This is just the example of the detailed 1 to 50 geological map in the southern part of Namibia, specifically in the Varambat map sheet. So the blue area here is just highlighted the pegmatite in the Varambat area that through this project, we're then able to really show the prominence of the pegmatite body in that particular area. And in the photo here, it's the Geological Survey of Namibia and the Council of Geoscience of South Africa team that have been involved in mapping this particular place. And for those who know the Gabi Schneider, the former director of the Geological Survey, he went to visit the team, and that's him. That's here in the background. Here we're looking at now the promotion of the minerals in the assessment of the economic potential. So we are looking at the pegmatite hosted feldspar and lithium, where with the cooperation of the BGR, we're able to produce two booklets that are looking into feldspar potential in Namibia and the lithium potential in Namibia. This is done in order for us to evaluate for the potential of this particular mineral in the industrial application in Namibia. And the Geological Survey also then published the dimension stones of Namibia in 2020, and the various flyers that look into the different commodities, for example, gold, cobalt, copper, and this is just an update from the orange book that I have shown you in the beginning. That now, instead of updating the whole book at one time, we look at each commodity at once, and then just give more light on what is at the ground. This is then the part of the work that the Geological Survey with the technical cooperation of BGR, who also then updated the map, where here now we are looking at the major pegmatite belt of Namibia, and this map was then completed last year. So you can see then the Varambat part here, where you have the pegmatite, and then you have these two areas here where you have the Uwis pegmatite and then the Karibe pegmatite. They are all in the Rongo region. Again, just trying to have information out there to the stakeholder that they needed. Here we are looking at then the drill map. It doesn't have all the information, but here we have just put some of the information and trying to see like how to better present it in an app. So this is we're trying to come up with an app where people can have information at the end, where they have their EPLs, and then they just want, before they come to the ministry, I want to understand if there is any drill that has been done in their EPL or something like that. They can then have that at their fingertip. So this is actually what we are planning to do in Ivare. And if we look at here, we can see the number of drill, the commodity, and we can say copper and nickel, and then a nickel and the PGA got a substantial number where you have actually the borehole done. And then if you go to this, but on this side, we had number of drill per commodity, you can see that the base metal and base metal, metal, you got a number of drill boreholes that has been done in the past. So this map doesn't represent all the drill borehole done in Namibia. This is just part of the data, and we are still working on it. The number that you see here in the map is just actually a number of drill that has been done per site. Here we then come at the geochemical archival data and the regional geochemical sampling project that we are carrying out at the Geological Survey. So here in red, you see all the archival data on the Earth Data Namibia that has been then populated and is accessible to the public. And the Geological Survey for the past years has been collecting stream and soil samples to enable to have a regional geochemical sample baseline for the country. And what they have done so far, they use the handheld XRF and did some analysis on the Okahanja map sheet. So what you see here is a soil sample where they're indicating the iron concentration in the soil in the part of the Okahanja map sheet. When we're looking at the collaborations, as I mentioned earlier, that Namibia has in the past done a lot of technical collaboration with different institutions and individuals, and we are saying Namibia is still underexplored in terms of modern mineral exploration and technology and concept. So basically, we're still looking out to collaborate more with others. And here is an example of then the collaborations that has been going in the past year. That is the in relationship to the 1 to 50 scale Southern Mapping Project, which is a joint project with the Council of Geoscience and the other institution, which resulted into the completion of 1 PhD, 4 master's degree, and 12 honor. So, and these are students from Namibia, from South Africa, and from other parts of the world. And we also had a remote sensing project, which we did with the JOCMEC, and here that photos, you're just looking at the Namibian and the JOCMEC Japan company in the field where we went to do some ground truthing. And through the expertise that has been gained through various projects, the Geological Survey is also been taking part in the PanAfGeo for Namibia, for the Pan-African support of the European and the Organization of African Geological Survey, where the Geological Survey staff are also being the trainers and as well as being trained. And when we're talking about then the opportunities, the collaboration with various key stakeholders and research, such as mineral potential mapping, prospecting modeling, and 3D compilations are some of the things that us at the Geological Survey are looking forward so that we can improve on the huge data sets that we have in order for it to be meaningful to the stakeholder and the exploration fraternity. Well, before COVID, the Geological Survey used to promote the mineral potential of Namibia at various exhibitions and conferences, and yeah, well, that includes in Durban, South Africa, PDAC, and yeah. When we're talking about the positive and constraint aspect, we're saying the Geological Survey has got a good structure, but not fully funded, resulting in understaffing. And well, we have many research opportunity at the Geological Survey, and we're saying loss of personnel to industry is one of the issues or the challenges that is enabling some of the projects to pick up and be finalized as we hope to. And we are also saying, like many other people, we have a budget constraint that sometimes you get money in the beginning of the year, and then because of other important projects that need to be focused on by government, then you realize that in the beginning you had a substantial amount of money, but in the middle of the year you are being told that you need to let go of some money for some emergency thing. And one of the things that we have at the Geological Survey, we said it consists of actually young generation staff, which are about 57% of them are younger than 35 years old. And then they actually motivated, and they are looking forward to engage with the local, continental, international researchers, so that at the end of the day, they can also empower what they have learned and also learn from others. Thank you very much.
Thanks, Ms. Nguno. Thanks for that presentation. And then Filipa, please, I give you the honor to introduce our second speaker.
Okay, thank you. Thank you, Anna, for this really nice overview and this presentation. So David Khoza is a geophysicist who worked in mineral exploration, mining, and geoscience research. After he completing his bachelor degree in geophysics, David joined BHP Billiton Mineral Exploration Division, where he conducts some geophysical surveys, primarily in Africa. David decided to take a break and then back into academia to complete his PhD, which is focused on understanding the tectonic evolution of Southern African lithosphere using magnetotelluric data. Following that, he joined Anglo-American Technical Solution Department, supporting several business units and brownfield exploration projects and research efforts with Anglo-American. Then he joined Spectrum Air, primarily focused on airborne electromagnetic data, processing, modeling, interpretation, and research. Currently, David Khoza is an executive manager, applied geoscience at the Council for Geoscience, leading the National Geoscience Mapping Program in South Africa. So David, the next 15, 20 minutes are yours, and thank you.
Thanks, Filipa. Can you confirm that you can hear me okay?
Yeah, I can hear you quite well. Thank you.
Okay, perfect. Thanks very much. And thanks to Anna, from the Geological Survey of Namibia. And this presentation is largely in the same sort of format, and talking about the number of projects that we currently are doing in South Africa, and looking for collaborative partners on some of these projects. So some of you may not know the Council for Geoscience, the same as the Geological Survey of Namibia. It's a state entity that is focused on geological mapping and essentially providing advice to the state on all manners of geoscientific studies. This is a laboratory in essence, both onshore and offshore South Africa. This is where most of the mapping activities are done in South Africa, also looking in the economic exclusion zone. I'll talk a bit about our effort in claiming some of these white bits as part of the South African territory in later slides. From a strategic point of view, the focus is really on these drivers for economic growth. That is essentially mineral resources development, energy security, groundwater mapping, marine mapping, looking at issues around community safety, which is geohazards, and infrastructure and land use. Meana already talked about the collaboration we do with the Geological Survey of Namibia, amongst others. And this is really in an effort to support many of our African geological surveys in their mapping programs. Some of the guiding principles that we are adopting is the National Development Plan of South Africa, the African Union's Agenda 2063, and of course the United Nations Sustainable Development Goals. This is partly where we also get our mandate in the geoscientific work that we do. Much more pertinent is the focus on limiting carbon emissions, and a lot of the geoscience research that I'll tell you about is a focus on how us as a nation can contribute to this net zero pathway of limiting carbon emissions by 2050. And I think it is fairly obvious that this just transition to the low carbon economy requires raw materials. We need to find them. We need to mine them. We need to mine them sustainably. And we need to get them out of the ground in a way that doesn't do harm to the environment. And the focus is on these so-called minerals of the future. And these are really the key minerals that are required to achieve net zero. So, as mentioned, the key focus areas for us are these that are listed here. And I'll talk a little bit about some of them and where we can collaborate and where we're looking for collaborative partners. So our approach is to map the Earth, in essence, at all scales. So what that means is that we need to collect all manner of geoscientific information from surface all the way down into the mantle lithosphere. And these are the type of data sets that we are currently collecting. And we believe that is the integration of all of these data sets that will lead us to not only understanding the mineral environment, but also the environmental or addressing some of the environmental issues, including issues around security. So these are the type of data sets that we collect, and that I'll touch a little bit on some of these and where people can find them. So as mentioned, the idea is to focus on these minerals of the future. And there's been a lot written on these, why they are important to achieve net zero. The problem is that we need to find them, and we need to find them fairly quickly. Copper, for example, is becoming quite a problem. And if we do not find any new copper deposits, it is unlikely that we will achieve this dream of net zero. Now, the other challenge that we're sitting with is that in many parts of South Africa, this is what it looks like, particularly the Northern Cape. This is, lack of exposed geology. So we need to see below that. And many people seem to think that countries like South Africa have been heavily explored. I do not agree. I think that there's still quite a lot of mineral potential that is sitting particularly below copper. So this map provides the overview of some of the projects that we're doing, and I'll touch a little bit in detail on some of these. The colored square blocks here, these are showing areas where we have done 1 in 50,000 scale geological mapping. And so as you can see, there's still quite a lot of way to go until we cover the whole country. We've given ourselves about 6 to 7 years to complete the full coverage at 1 in 50,000 scale geology. And in addition to that, there's a few minerals projects that we're focusing on that are really meant for encouraging exploration and making this information available so that explorers can use it and build their own exploration programs that way. So I mentioned all the data sets that we are busy collecting. This is as well geochemistry data, also in the Northern Cape. And if you zoom into one of these areas, this is what it looks like. For every 1 kilometer, we collect a soil sample, and we do all manner of analysis. It's about 49 elements that are assessed there. And this is done on a scale of 1 in 50,000. So the idea is that we cover most of the country with soil geochem in about 67 years. And we've gone a fair bit trying to get as much information as possible, and it's obviously an overwhelming information for us to look at. One of the critical things that or critical data sets that we are collecting is airborne electromagnetic data, and this is one key data set that has been missing. Most of the country is sort of covered with high resolution magnetics, but it's the airborne electromagnetics and the airborne gravity radiometry that is missing. And over the next couple of years, we'll be collecting quite a bit of those data. We started with the airborne electromagnetics, also focusing in the Northern Cape, because that's where we think most of the deposits will come from. In order for us to map the lithosphere, we're collecting quite a lot of magnetotelluric data and seismic data. This is information at roughly about 20 kilometers or so. With every point, we are collecting both magnetotelluric and seismic data. And these sort of arrays, many countries have done these things. I think the US and Australia being the prime example. And it makes a lot of sense because this in order for us to find mineral deposits, we need to understand the lithosphere, the nature of the lithosphere, and the tectonics in general. So I just want to talk to you about a little bit about some of the work that we've been doing in trying to characterize particularly SEDEX, lithium in pegmatites, and mafic, ultramafic hosted nickel copper cobalt. So this map here shows the area of focus in essence, and this is where a lot of the work has gone in to try and map geology undercover. And this means we must essentially collect an integrated data set that we can use to characterize these type of deposits. So we've used the airborne electromagnetic data, we've used the airborne hyperspectral data, which is shown here in pink. We've used the MT data, and we've used the soil geochem data to characterize some of these deposits. And the high resolution magnetics and electromagnetics data has given us pretty decent structural information, and also information that we can infer a lot of the geology. And here we are targeting specific horizons. In this case, it would be the Hudson formation that is associated with these SEDEX deposits. From the electromagnetic data, we have done a lot of inversion modeling, EM inversion modeling, magnetic inversion modeling, to not only characterize areas where these deposits could be, but also understanding the three-dimensional geology. In terms of the pegmatites, this is where some of these are mineralized, and they have a lot of lithium. And this is what they look like on outcrop, but some of these are really undercover. And what we've done through the 50,000 scale geological mapping is to try and map out where they would be. And both in Namibia and in South Africa, we've basically highlighted in a lot more detail the pegmatite density, if you like. And this map shows every single pegmatite plug that we have mapped out in this area in the Northern Cape. This is on the border between South Africa and Namibia. And you can see that there's quite a lot of information where we've highlighted areas where these pegmatites could be. And a lot of these require further work, further drilling. And given that lithium is one of these minerals of the future, this presents a good opportunity for explorers to look at. Now, from the energy side, the focus is not only on understanding these energy minerals, but also looking at new energy sources. And this is really towards this idea of a just transition to a low carbon economy. And in this sense, we're looking at geothermal energy. And there are several areas that we've mapped out in black here that have good sources, what could potentially be good sources of low enthalpy geothermal energy. And we've done quite a bit of work in some of them, doing magnetotelluric data collection, inversion, to try and understand the source of the hot rocks. And in this case, in the Limpopo area, we've mapped it out to a depth of about 2 kilometers. And this is associated with the known hot springs. Some of these hot springs are about 45 degrees water surface. So the idea is that the waters would be quite hot down at depth. And the idea is to put these sort of geothermal energy generation plants on surface so that we can exploit these hot sources. Now, this is where we need collaboration. And this is a program that we are currently efforting in carbon capture utilization and storage. It's the first of its kind in South Africa. And we have done quite a bit of work in trying to locate potential storage sites, both onshore and offshore. And we've located a site onshore, in this case, in the eastern part of South Africa. And this is closest to the major carbon emission sources, the coal-fired power stations that exist in the area. And for those of you who know South Africa, Sasol's Secunda plant is about 20 kilometers from this site that we've selected. And the site is surrounded by a number of coal-fired power stations, a number of coal mines in the area, and we've identified a suitable geological formation. In this case, we're targeting these porphyritic lavas of the Fantas supergroup. They're sitting just above the Witwatersrand supergroup. And these have proven to be quite a good source for injecting CO2 at about 1.2, 1.3 kilometers. So we are hoping initially we will extract or will inject about 10,000 tons of CO2 as a pilot. If that proves to work successfully, we'll upgrade that in the next couple of years. The collaboration that we need here is really focused not only on site characterization, but also on modeling the behavior of CO2 in porphyritic lavas, for example. There's, I think, one project that has been successfully done, I think it's Iceland, where they're doing the same kind of work. So, in addition to sequestering carbon dioxide, the big focus is on the utilization, and this is what else can we use the CO2 for? This is work that is focused on the creation of new materials, carbon fiber materials, fertilizer production, for example. But probably a lot more exciting for us is the treatment of mine water, in addition to doing sequestration using CO2. And this is quite an exciting project for us. We have a lot of problems with acidic mine water. And it is through this program that we hope to treat as much of these waters as possible. In terms of the work that we're doing, I mentioned the marine mapping program. This work is focusing largely on the economic exclusion zone, which is shown here in red. We're focusing on the continental shelf, just off the shelf as well, collecting all manner of marine data, magnetics, bathymetry, and all of those things. But also from a minerals point of view, looking at these offshore type deposits, and not only oil, but also these some of these base metal deposits. And we've started a couple of years ago by mapping the near shore. And we have our own vessel that we use that goes to about 80, 100 meter waters. And that's kind of been very good to us in terms of collecting high resolution data in the near shore. And we've collaborated with the Navy, believe it or not. They have their own boats that they're doing a survey in the marine environment. And we're also looking into acquiring these unmanned vehicles that basically can leave going for a number of days in the ocean. And this is the type of information that we get from the small vessel that we have currently that's working in the near shore. For those of you who know, this is Robben Island, that's Cape Town there, and this is the type of information that we're getting. And this is giving us good information on the structures, some of which extend onshore and offshore. So the structural information in particular has been quite useful. Now, what we're also doing is we're trying to exploit this fast-moving Agulhas current for generating energy. And the idea is that we put these type of turbines on the ocean floor to exploit the Agulhas current. It's one of the fastest moving ocean currents in the world. And hopefully we can use that to exploit or to generate some energy there. Another collaborative program that we're looking at is with Antarctica. So in the South African geological sense, the part of the Kapval Craton is sitting in Antarctica. It's part of the Nguno Craton. And we're trying to understand how this, from a tectonic point of view, how the Kapval Craton evolved, and obviously how the global plate tectonics evolved through time. And the idea is that we collect quite a lot of data in the Nguno Craton in Antarctica to understand the lithospheric dynamics there and see whether there's any correlations we can make out with what we're seeing in the South African side. And for that, we are collaborating with the Navy, but also with the Department of Environmental Affairs, who are operating this SA Agulhas 2 icebreaker, which is the one that goes to Antarctica on a regular basis. And we're hoping to put a lot of seismic stations there, MT stations there, and we've collected 20,000 geological samples in Antarctica that we're busy doing analysis on. Much more recently, you might have heard that the SA Agulhas was responsible for locating the expedition team that was led by researchers, number of researchers in South Africa and in the UK, and they located the Endurance wreck, which was this Ernest Shackleton ship, which disappeared around 1950. They were quite successful in locating that ship using the Agulhas. Now, in terms of the extended shelf claim, I mentioned that part of the idea is that some of these become part of the South African territories. And for that to happen, the application we need to put in there needs to have geological support. And that means that we need to do quite a lot of geological mapping in the deep oceans, also in the South African islands, to prove, in essence, geological continuity. So that these areas highlighted here can be claimed to be part of South Africa. And from a groundwater mapping point of view, we've developed this in-house software that uses machine learning type algorithms, looking at mapping groundwater and predicting where groundwater could be. And this is quite an exciting project that we've been doing quite successfully in some places where it's been applied to locate these water sources in areas where there hasn't been or water supplies is quite scarce. So all this information that I've shown you is available on this Geoscience data portal. I can put the link there on the chat, and you'll be able to get it there. The geophysics data, the geochemistry data, and some of the other information is there. So we're basically looking for people, particularly on the carbon capture, utilization, and storage. We're basically looking for collaborative opportunities there because this is where we think that the program can quite rapidly be upscaled to other areas, and we'll be happy to chat to anybody who is who's interested. And that's it. I'll leave it there. Thanks, Filipa. Thanks, Halleluya.
Thanks, David, for that amazing talk and for sharing the amazing work that the Council for Geosciences do. There's a question to Meane from Malcolm. Malcolm says, thank you for a great talk. You mentioned extending your airborne EM coverage in the east of Namibia. Do you have any specifics to the blocks to be covered and the type of EM method that's going to be used? Meane?
For the EM method that is envisaged, it could be, maybe they are going to use the B term or the Z term or the term best. Out of these for now, which of the method that the geophysics division is going to use. But my colleague Bofelo is online. He might be able to type something in to see whether they have really made up their mind which of the EM method they're going to go for.
I have a question for Anna, but maybe a more broad one, and it's curiosity based on some of my experience and other countries. So, Anna, usually the big budgets come from the big companies, and frequently they do a great job on geological recognition and give some geological information for the different countries. So my question is, are there any agreements between the companies and Geological Survey in order to give the information to the Namibia government? Because as I know, in some countries there are, but in other, you have a lot of companies doing great work on the site, but then there are some information that is lost on this transition. And for that reason, you have information, but not information organized, or I'm not sure if I am being clear.
By law, the company that are doing exploration, they are supposed to give data to the Ministry of Mines and Energy, and then which is at the Department of Mines, but then a copy to the Geological Survey. Then upon the language of their EPL, then this data become public available, which then the Geological Survey take it and then scan it and put it in the Earth Data Namibia that I've stated there. If it's not yet scanned, people can still get access to it by coming to the library and then look at the particular data. Yes, of course. There are data that are supposed to be with the Ministry or with the Geological Survey, and the question is sometimes, did we as the ministry misplace the data, or is it the company that hasn't brought in the data that is supposed to be given in to the ministry? But the law kind of like provide for that companies, when they do exploration data, they need to share it with the Ministry of Mines and Energy. There are companies that work in Namibia and share freely information with the Geological Survey of Namibia, And we are really grateful to those companies because with the information that they gave us is actually the ones sometimes when we look at it, we are able to update our geological map database. Because in some years back, we really used to get a lot of help from the collaboration with the university, but mapping is no longer in fashion. So most of university don't come to Namibia anymore to do the basic mapping. It's only some university that still comes, and then once they have done that, they share the data, whether it's data or maps that they have produced, and then we incorporate it into our data sets with acknowledgement where we got the data, of course.
Okay, thanks.
Thanks, Anna. We have two questions for David. And for the first one, I would like to ask, and apologies for mispronouncing your name, Bijan Van. You please go ahead and ask your question.
Thank you to David and to Anna for the great talks. I enjoyed them both greatly. Exciting stuff that you're both doing. David, just from what we saw in Anna's talk with that cadastre, the mining cadastre, which is quite transparent and freely available, I think one of the big drawbacks in South Africa is that we don't have one of those ones. And I was just wondering whether there were plans in place for us to get one like that, and whether it's your responsibility as a CGS or whether it's a DMR, and whether there's some timeframes in place where we can see that to start attracting more investments into our mineral sector.
Yeah, thanks, Bjorn. If there's one thing that is a serious inhibitor in exploration in South Africa is having that publicly available cadastral system, and there's been talks about this for many years, and it's not the responsibility of the Council for Geoscience, it's the responsibility of the department. And we've been trying very hard for the past couple of years to support them to get this system underway. And I believe there was some sort of a bid out last year sometime to get somebody to develop this system. I'm not sure what the timeframes are, and obviously it's being the function of the department. Some of those things we are not privy to, but hopefully something will be done in the next couple of months. At least the minister is committed that this will be available this year.
Thank you, David.
Thank you.
We have another question for you, but I believe the last part of the question can be extended to Anna, if you have any comments in the end. So the question is from Alex Brokov. So David, thank you for the great talk. CGS is doing great. He's asking, can you share update on the RSA MT coverage? How many stations acquired, challenge, and so on? And the other part of the question is, any opportunities for Namibian Geological Botswana to extend the MT coverage in Botswana and Namibia?
Yeah, thanks, Oleg. So with the MT, we decided basically to start in areas that are undercover, and that's why we started in the Northern Cape. And we are sort of halfway through with the instruments that we have, but we have bought additional gear now, MT gear. So hopefully that will we'll see us accelerating a little bit in coverage. Through the Organization of African Geological Surveys, we are hoping that we will develop a continental scale MT acquisition program that will hopefully see us extending some of these arrays into Namibia, into Botswana, and other countries. We saw how successful it was with some text that was collected a while back, and it only makes sense that it's extended. These arrays become the norm across the continent.
Thanks, David. There's another question for you, David, from German. Thank you, David, for this very informative talk. One, on the pegmatite-related map that you presented, it is viable that pegmatite rocks cover a space that extends from west to east in South Africa. Is there any regional fault that may have controlled its emplacement? If yes, can you please tell us more about this?
Yeah, so I'll be happy to share a report with you on the thinking behind how these pegmatites were were emplaced, but certainly there is a structural control in a lot of these. And because we're finding them in multiple terrains in the Namakwa, they appear also like there's a time, almost like a time control to them. So there's a pulse that came in at a different time in one terrain and a pulse that came at a different time in another terrain. But I'll be happy to share with you the geological and structural work.
Thanks, David. David's email address is on the screen. So if any of us would like to reach out to David, please feel free to send him an email with address to the email on the screen, as well as my Anna's email address should be on the email sent out with the discussion. So please, if you have questions regarding the work, the opportunities that these geological surveys present, please feel free to reach out to the individuals that just gave the presentation. It does not look like we have any more questions in the chat, and we are...
I have a quick one,
Okay.
Halleluya, just to finish the session, maybe. For Anna and for David, you both show a lot of different opportunities in your countries, but I would like to know in a strategic way, if you have to choose one or two commodities, which one do you think your countries are more interested to go?
Well, I mean, if you ask me, I'll go for the copper, because, well, copper is used everywhere, and it will go a long way. But then on the other hand, I haven't mentioned a bit more of iron, but I'll say I am an iron girl, so I'll choose iron.
Yeah, I don't think there's any one or two commodities. I mean, we have very various geology in South Africa and in Namibia, and the geology gives us an opportunity to look at particularly these minerals of the future, and we have to look at those. Unfortunately, there's quite a few to look at, but it also gives us a very good opportunity. But as Anna mentioned, to me, I think copper would be a serious problem in the future, and it's one that we're paying particular attention to in terms of trying to encourage exploration, particularly.
Okay, thank you. Halleluya.
Let you go. If this was an interesting talk and you'd want to hear more about the geological survey work, and also how we have a panel discussion coming up at the SGA, that will be next week, and it's entitled Lifting the Hood on the Relationships Between Academia, Industry and Geological Surveys. That will be on the 29th of March. So if you've registered, please do attend. And we have a panel discussion made up of amazing speakers: David Koch, we have Glenn Naira, Santa, Nguno, who just presented, Kathy Agri, and then we have Robert Kimber. So please do make sure that if you've registered for the conference, the SGA conference, do make sure to tune in the panel discussion. I'm sure it will be full of exciting and fruitful discussions. So from myself and Filipa, we thank you again for your continued support. And our Deposits Hub will not be what it is without your support. So continue supporting us and continue sharing your knowledge with the economic geoscience community. From myself and the Deposits Hub, it's goodbye for now, and see you in a few hours' time for our afternoon session, which is at 5 GMT time this afternoon. So goodbye and do take care.